Good morning, students. Today we will discuss about air conditioning process. What is the necessity of air conditioning first? Methods we will discuss later. The human comfort. One thing is the human body is a heat engine. Continuously respiration load. Continuously we are dissipating heat. We are rejecting heat. In a normal condition, in sleeping mode 87 watt and general working like office work like us 115 watt rough figure sampling for medium strain condition physical exercises or play games playing at that condition 230 watt heavy works are there physical work in workshops manpower is doing at that time we are releasing heat 440 watts means continuously as a heat engine we are rejecting the heat like engine we are supplying the fossil fuels here we are supplying food first thing so whatever the heat is rejected by the body immediately we want to remove that first one. Second, for the human comfort, second thing relative humidity because if the body is alive sweating is come continuously body releasing some moisture also some of the body may release excess moisture some of the body may release less moisture but continuously we are rejecting moisture also that moisture evaporation is required then only our skin will feel comfort that evaporation purpose whatever the air we are sending okay I control the temperature and I remove the heat that air having the high relative humidity means it will not absorb that moisture automatically we will feel uncomfort even though temperatures are controlled in the room if we feel uncomfort so maintain relative humidity inside the air generally 40 to 60 percentage we are maintaining the relative humidity based on the conditions in South India 60 we are maintaining in North not South India in coastal region in Rayalaseema or Hyderabad like that there we are maintaining 60 relative the condition is 40 to 60 we are maintaining. Third thing I already mentioned different types of works different heat release is there so what we want to do we want to remove the heat means velocity, volumetric flow rate of the air is important. Velocity of the air. These three is major driving force we want to maintain continuously for air conditioning system. For this purpose, what are the methods are available in air conditioning? We will discuss today's class. Suppose simply just cooling sensible cooling this is called sensible cooling psychrometric chart I already explained you know this is the saturation line this is the dry bulb temperature this is the specific humidity lines these are the wet bulb temperature line remaining same lines cooling dry bulb temperature is increasing minus 10 to 60 so sensible cooling only cooling we are doing just air conditioning system evaporator is kept inside the room automatically cooling will take place only heating just you place condenser inside the room the same system vapor absorption compression system condenser you place inside the room simple heating sensible heating will take place humidification spray the water vapor automatically air relative humidity will increase or dehumidification cool the air up to dew point temperature moisture we can remove or combination heating humidification heating dehumidification cooling humidification cooling dehumidification these are the combinations ultimately for year round air conditioning system we are using the combination of methods in this unit just we will discuss types of air conditioning process The combination methods, and upon that some problems will solve in next applied thermodynamics. These are the 6 methods generally we are following for the year-round air conditioning system: sensible cooling, sensible heating, cooling and humidification, heating and humidification, cooling and dehumidification, and heating and dehumidification. Now we will discuss one by one. Direct psychrometric chart I will explain. It is easy. Sensible cooling. What happened? I am reducing the dry bulb temperature simply. Once you reduced the dry bulb temperature, the wet bulb temperature also reduced. You can see we are reduced dry bulb temperature only. Just simple cooling. Evaporator coil I place inside the room. I will get the sensible cooling option. You can reduce the dry bulb temperature. Wet bulb temperature also reduced. But dew point temperature is not reduced. In this point or this point, dew point temperature is same. There is no change in specific humidity, but relative humidity is increasing. You see, the relative humidity here may be 30% or 40%. Just sensible cooling, the relative humidity of the air also increasing. So relative humidity is increasing, but specific humidity, dew point temperature is not changing, and wet bulb temperature is decreasing, and enthalpy also decreasing. We are cooling the air. Next method, sensible heating. Here same, we are increasing the dry bulb temperature, wet bulb temperature also increasing, but like sensible cooling, dew point temperature and specific humidity is not changing. Dew point temperature and specific humidity is not changing. Enthalpy is increasing. Why? Because I added heat, automatically enthalpy of the air is increasing. How we are achieving this sensible heating means just I place condenser coil inside the room and evaporator coil outside the room. Same vapor compression refrigeration system. I can achieve sensible heating easily. Next, cooling and humidification. You see, I am reducing the temperature and I am increasing the relative humidity. Both I am doing at a time. How I can achieve? By general coolers. What we are doing? Cool water I am spraying upon the air. Automatically air temperature is reducing and humidity also increasing. Just spray atomized cool water upon the air. Automatically it will decrease the temperature and increase the relative humidity. So by this operation, you see, initially temperature is enthalpy is H1. Enthalpy is increasing. Why? Because the moisture content is increasing means the enthalpy of the water vapor is high, automatically enthalpy is increased. Specific humidity is increased. Why? Because moisture of the air we are spraying means absorption rate increased. The specific humidity is increasing and dew point temperature is changing. Earlier dew point temperature this one. Now dew point temperature increased and wet bulb temperature also increased. Relative humidity also increased. Next method. Heating and humidification. Same method. Instead of cooled water, now we are spraying hot water upon the flowing air. Automatically it will humidify the air and it will increase the temperature also. In this condition also, enthalpy is increasing. Why? Because we are heating and humidification. In both cases, enthalpy is increasing. Dew point temperature is increasing. Wet bulb temperature increasing. Dry bulb temperature automatically will increase. And specific humidity is increasing. Why? Because we are increasing the moisture content. Specific humidity means moisture of water vapor by total moisture, total mass of water vapor by total mass of air. Next one, cooling and dehumidification process. See, cooling and dehumidification process somewhere here. I want to remove the moisture means what I am moving up to dew point temperature. Then only Less than dew point temperature I am moving, then only I can remove the moisture. Same, evaporator coil you place inside, determine the dew point temperature, cool the air below the dew point temperature, automatically cooling will take place and moisture we can remove. So the second state, dew point temperature is changing. Second, once we are removing the moisture means automatically water vapor enthalpy is reducing. The mass of water vapor is reducing means enthalpy automatically reducing. And specific humidity also is reducing. Why? Because we are removing the moisture. The specific humidity is reducing. Wet bulb temperature also reducing. Dry bulb temperature automatically cooling means it will reduce the dry bulb temperature. Next process, heating and humidification process. The heating and humidification, how we will achieve first thing. Actually, silica gel and Al2O3, aluminum. Adsorption phenomena. These are the solid materials. While air is flowing upon the solid material, it will absorb the moisture. The porous material absorb the moisture. At the time of adsorption, due to friction, temperature will rise. Special heating is not required. Adsorption process, while it is absorbing the moisture from the air by this porous media, silica gel or Al2O3. Due to that friction, automatically heating of the air will take place and removal of the moisture. But what happen after some time, it will reach saturation condition. Again, same disk. We are heating up to 150 or 200 degrees temperature. Total water vapor will evaporate. Same disk again we can use for next cycle of operation. So every time you want to change cyclic operation every 1 hour, 2 hour based on the removal rate of the moisture. We want to change the this adsorption disk. Generally, two materials we are using. First one silica gel, second one Al2O3. Al2O3 desorption temperature is around 200 degrees. Silica gel 150 to 165 degrees. It is required. So by this operation also you can see we are heating and we are removing the moisture. In this condition also light increase of the enthalpy. Why? Because due to heating. But specific humidity is reducing because moisture we are reducing and relative humidity is reducing, moisture we reduce, so relative humidity is reducing, temperature is increasing and dew point temperature also is reducing drastically initially from here and finally we are reducing the dew point temperature. So these are the 6 methods how we are achieving also explained. A psychrometric chart representation, by representing of the psychrometric chart we visualized the process. I think with this I am ending the session. Thank you. Thank you very much.